Okay, we're going to go ahead and address how to figure out your I can statement that says um, that you can use the diagram you can use a phase change diagram to answer questions. So we're going to look at what's called a phase change diagram. Some people call it a triple point diagram, although basically what you have is this diagram here. And if you look on your y-axis, you have your pressure over here. And down here on your x-axis, you have your temperature, which is in degrees Celsius, because that's what we use here in science. So I'm just going to go over a few basic things with you really fast so that we can clear up some misconceptions, I guess, or misunderstandings, or in case you just didn't hear it or you were absent, here we go. Okay, so what you have on your triple point diagram is you have a graph that looks like this, and over here going up you have pressure, and then down here on the bottom you have temperature. Okay, so as you go in this direction, temperature increases. As you go in this direction, temperature increases. That does not mean you can't have a negative right here. If you look, for example, on your practice graph, 0 is right here. So there are negative numbers, and that's okay because things can go below freezing. So what you have on this diagram that you're looking at here is temperature increasing, and as you go up, pressure increases. Now, most triple point graphs look kind of like this. And as you can imagine, what we're mainly looking at is this area right here where we have a triple point. But it is a phase change diagram. So what are the phases of matter? Well, we have solids, we have liquids, and we have gases. So in general, at a really high amount of pressure, which would be up here, and at lower temperatures, think about ice cubes, they're solid. When they're frozen, they have a low temperature. So these guys over here on this part of the graph where you're at a lower temperature and higher pressure, this is going to be your area where you have solids. Okay. After that, you can imagine in this area in between, and I could have drawn it a little bit off, so don't quote me on that. This area right here in between is going to be a area of liquids only. And then this area over here on the right hand side, this area is going to be your gases. And so each one of these areas explains what it is that you have that you're looking at. And remember, go back to your molecules. You remember the little boxes with your polka dots in them? You have your boxes with your really well packed polka dots for your solids. You have them closely packed together, but kind of jiggling or whatever you want to call it, but still able to move freely around. And then that's their liquids. And then all over the place, you have your gases. So in this particular area, you have solids. You have much higher pressure, but down here, you have lower temperature. Okay. And in the middle, you have your liquids. So once you get into your liquid area, you have kind of like the mid-range on everything. You still have somewhat of a high temperature and somewhat high pressure. And you're in between the most high pressure phase and the least pressure phase. So over here, you have your gases. And in the gas stage, you're going to have your particles, which are very freely moving about. They have a lot more energy. They're very far apart. That's where you have a lot more space in between individual molecules. Like, for example, if we're talking H2O, you're talking that you have lots of H2O only molecules in this particular instance, but they're spread out. There's a lot of space between them. And they also are going to have collisions with each other. So they collide together, okay? There are two really important points to know about the graph. One of them is up here, and the other one is down here. Now, I already mentioned this one. This is what is called the triple point. So in order to understand what the triple point is, you need to also understand what these lines represent. Because this line right here, this first line goes all the way up. This area right in between here, if you are on this line, you are at a state of equilibrium where you are in between solids and liquids. And that doesn't mean necessarily that you have to be a little bit of each. What it really can mean is that just as many particles are going from the solid state to the liquid state as the same number of particles are moving from already being a liquid to becoming a solid. Okay, so it's really about the transition between the two. It's the change in the pressure, the change in the temperature, and it's the back and forth motion. At this line, you have equal amounts of transitioning substance molecules, whatever, from one state to the other. Okay, the same thing is true at this line right here, although it's between liquid and gas. So in between this right here, these two areas on this line, you have the transition from liquid to gas. So you have the same amount of particles that are a liquid that are becoming a gas. And then you have the reverse of that. You have particles that are a gas becoming a liquid. And if anybody could already guess, this line right down here, this is your line of sublimation. And this is what we saw with carbon dioxide in class when we had that. So on this line, you have sublimation. So you have the items, the molecules that are sublimating, and then you have the items that are depositing. Okay, so in one place you have things that are going directly from a solid to a gas, and in the other you have things going from a gas back to a solid. So the same thing happens. You have solid to gas, or you have gas to solid. Okay, so that's that. Now that'll help you understand these things. At this particular point right here, it's called your triple point. The reason it's called a triple point, you guessed it, you have 1, 2, 3 major states of matter, and they all exist at that point. And what that means is exactly what we see here, here, and here, except in this case, you have the same amount of particles going from solid to liquid, from liquid to gas, from gas to solid, from gas back to liquid, from liquid back to solid, all happening at the same time. So that means that the perfect conditions are present for all three of those to exist. Now, the other really important point is what you get out here, and this is called your critical point. This is your critical point up here, and this has to do a little bit more with density, because as you might imagine, maybe you've never thought before, what happens exactly after you become a gas? Let's take H2O for example. What happens after you boil water? Well, after you boil water, water reaches that temperature of 100 degrees, and after that, it is boiling. It becomes a vapor or a gas. So how high, though, can that go? It actually can go quite high. There is no upper limit at which that has to stop. So the temperature can continue to rise, and you end up getting to a point up here somewhere in between these two areas where you have a great deal of liquid that is starting to become more chaotic and more spread out like a gas because it's under so much pressure. You also have, because it's at such high temperatures, and you also have a great deal over here, say here's the liquid, and then over here you have a great deal of gas particles that are starting to behave more like a liquid because they are under such high pressure. So let me say that again because I kind of went backwards. Over here, a little bit left of this critical point, your liquid particles are they are exposed to such high temperatures that they are acting more and more like a gas. Whereas your gas particles, exposed to high temperatures as well, are also being exposed to such high pressure that they're starting to act a little bit more like a liquid. And so this critical point is the point at which whatever substance you're talking about, today I'm talking mainly about water just because it's something everybody recognizes. The critical point is the point when water quits acting like a liquid or a gas. The line that distinguishes being a liquid or being a gas is blended or gone. And at that point, that particular substance is considered to be at a critical point where the density between the volume of it, the gas, how much space it takes up, and the behavior of the molecules is really neither a liquid or a gas. Okay, so hopefully that will help you guys a little with that. Now, let's go back and look at these questions right here, and let's see if we can't figure out how to answer them a little bit. So if you're looking at these, you have exactly the same thing that you had just a moment ago. Let's see, I have a little glare there. So when you're looking at these questions and you're trying to answer them, the first thing says to label the diagram solid, liquid, and gas, triple point, melting point, freezing point, boiling and condensation, and sublimation and deposition. Now, I would be willing to bet that having just drawn that on here we can figure out exactly what that is. So those things, I'm going to let you guys use the other graph for. What states of matter exist at the triple point? Well, the answer to that, number 2, I'll write down here. What states of matter? All of them. Good answer. Solid, liquid, and gas all exist. Okay. At what temperature and pressure is the triple point for this substance? And that's an important thing to say, because while I've been using water as my example, there is a phase diagram for every substance out there, not just water. So at this point right here, obviously you figure out how to do that by drawing your lines down, and you can figure out your triple point for this particular substance. So what this says is, what is the temperature? And I would say that for this one, the temperature is 100 degrees Celsius. And for the pressure, based on this, I would say if they go up by 0.25 every time, I would say that it's 0.70 and it's ATM units, okay? And it says a substance is at a pressure of 0.75 ATM and a negative 100 degrees Celsius. At these conditions, the substance is a blank. So let's make sure you find your negative. This is negative 100 degrees, and we're at 0.75. So just draw those out until they intersect, and they're going to intersect for you right there. And what part of the diagram is this? You've got your solid, liquid, and gas. And so in this particular case, that would be a solid. Suddenly, the pressure drops to 0 ATM, which is abnormal. That's below what we have. What phase changes have occurred? So this pressure all of a sudden drops from right here. In this case, we're assuming from the answer from number 4. So the pressure all of a sudden drops down to 0 ATMs. Well, if you're still at 100 degrees below 0 or negative 100 degrees, and now you're at this pressure, what phase are you going to be at there? Well, you should be able to draw your line over and figure out that this is in the gas phase. Okay, and you get all of that just by reading your graph. 6 says a substance is at a pressure of 1.0 atm and negative 100 degrees Celsius. The temperature increases to a temperature of 600 degrees Celsius. What phase changes has or have occurred? So this is asking you to have a before, and this is kind of like our gas laws a little, and then you have an after. So in other words, a change has taken place. The change is you started out at a pressure of 1.00 and a temperature of 100 degrees. And at the end, you went from negative 100 degrees Celsius all the way up to 600 degrees Celsius. Now, interestingly enough, you could actually change that and use your own calculations in your gas laws to figure out the answer to that. But since that's not what it's asking here, we'll just do what it says. And we'll pause right there for a second. Okay, so a temperature that at this particular situation, we're talking about going from negative 100 up to 600 degrees Celsius. And the question is asking what phase changes or change have occurred. So you're going to start here at the negative 100 mark, and you're going to go all the way up to 600. And it's at a constant pressure, in this case, of 1.00, which is right there. So we're going to have a constant pressure all the way across. So now anywhere on this line, if you stay at this pressure and you go from right here to right about here, what phase changes has happened or have occurred? So first you started out with the phase of a solid, then you crossed this line into the phase of a liquid, and then eventually you end up as a gas. So the answer for that would actually be that you have been all three. You were solid, then liquid, and then a gas. Okay, so hopefully that will help clear some of that up on phase change diagrams. See you later.